So let's start with this differentiation of application using stationary points. Okay, before I start, let me explain what is it. Okay? Okay, so over here, so I'm going to just draw so mainly is I'm going to talk about stationary points. Okay, so let's say I have like that. Okay, pardon for my drawing. Hi, good evening. Okay, so this one a bit ugly. Proving is behind, second segment. Now we are doing differentiation of stationary point. So look at this function, this graph, okay? So we have stationary points are the turning points. Okay, so for this case, you can see that these are the stationary points. Okay, so and you know that by now you should know that dy dx is gradient of tangent, right? Gradient of tangent. So you must know that dy dx is actually the gradient of the tangent. Okay, gradient of tangent. So you see at the stationary point, if I'm going to draw the tangent line, okay, it will be a horizontal line. And for horizontal line, the gradient is 0, right? So the gradient is 0. In other words, dy dx is also equals to 0. Okay, so at this turning point or stationary point, same thing, we'll draw the gradient, the tangent line. It is again horizontal line. Hello, this one is Sec 1. Differentiation is usually learned during Sec 4, AMath. Okay, so again, my gradient is 0. It means that dy dx equals to 0. All the stationary point, all the turning point, the gradient is 0. dy dx equals to 0. And that is why when we want to find out what is the stationary point, we always form the equation dy dx equals to 0 to find out what's the corresponding x. Both NA and Express also learn stationary points. Okay, so that's the reason why for stationary point, you always just find what is dy dx equals to 0. And that will give you the stationary points. Then the next thing is, they will always ask what's the nature. What is the nature of the stationary point? Okay, so stationary point is the same meaning as turning point. Maybe you are used to seeing what is turning points. Okay, in coordinate geometry, you see what is turning point. Okay, in differentiation, they call it stationary point, but they are the same meaning. Same meaning. So these two terms is very general. Okay, it's very general because it can mean it's a maximum point, it can mean it's a minimum point. No, today I'm doing stationary point. No, I'm giving explanation of stationary points, then I will do some questions on that. Okay, so basically stationary points, okay, we need to know that nature, you have 3 types. Okay, 3 types of point. You either say that it is a maximum point, okay, minimum point, or you will say that it is a point of inflection. Okay, so when they say find the nature of the stationary point, you need to find out whether is it a maximum point, minimum point, or is it a point of inflection. Okay, so to find out the nature, we have 2 tests. Okay, we have 2 tests, 2 types of tests. Okay, you have first derivative test, or second derivative test. Okay, so under this second derivative test, okay, when our d square y dx square is more than 0, we will know that it is a minimum point. when our d square y dx square is less than 0, it is a maximum point. Maximum point. Then, if you get your d square y dx square is equals to 0, cannot determine. Use first test. Okay? When d square y dx square is equals to 0, you cannot determine that it is point of inflection. Okay? You will have to use the first test to find out. Okay? So, this first test, okay, this first test, so usually what you need to draw is, you need to draw a box with 9 boxes. Okay? 9 boxes. So, if you get this is a maximum point. Okay? If you get this is a minimum point. If you get this, or this, these two conditions, they are point of inflection. Okay, so basically stationary point is just like that. Main thing is dy dx is equals to 0, and finding the nature, you will have the first derivative test or second derivative test. So usually I will use second derivative test because it's easier. Only 2 cases, 2 situations whereby you will use first test, and in fact 3 situations. Okay, first reason is if my second derivative is very difficult to differentiate, okay, then I will use first test. Secondly is when my d square y dx square give me a 0, then I have to use first test. Okay, then difficult, this one, and first test. Or if the question say use first derivative test, then of course you cannot use second derivative test. Okay, so 3 situations whereby you cannot use second derivative test. Okay, so this is the so-called summary of my stationary point. Okay, so let's start with the question. Can go through how you differentiate. No, I already teach differentiation 5 rules in the previous TikTok. Please refer to my previous YouTube video on that. I'm not going through the basic of differentiation. Okay, let's start with the first question. Okay, this one. First, they say that the equation of the curve, hello, that's my sister. Just done. Okay, y equals to x cubed plus px squared. Okay, they ask you to show that the origin means 0, 0, is a stationary point on the curve, and also find the x coordinate of the other stationary point in terms of p. Okay, so every time they ask you to find stationary point, you need to find dy dx equals to 0. So first, write out our y first. Y is equals to x cubed plus px squared. Then let's find out what is our dy dx. So differentiate x cubed, bring down the power, so it's 3x squared. Okay, plus bring down the power, so it becomes 2px. So this is our dy dx. So do not panic and wonder, I got p inside, how am I going to solve my dy dx equals to 0? It's okay, just proceed to do it first. So then after that, you know that I want to do for dy dx equals to 0, because I want to find stationary point. Remember, to find stationary point, always find dy dx equals to 0. So it means it becomes 3x squared plus 2px equals to 0. So I want to solve this quadratic. I will take out common factor, x. So take out x, you get 3x plus 2p equals to 0. So you get x equals to 0 or 3x plus 2p equals to 0. So my x equals to minus 2p over 3. Okay, so that's 1x and that's 2x. So when you have 2x, when you do dy dx equals to 0, it means that you have 2 stationary points. Okay, if you have 2x means you have 2 stationary points. So we have 2 things we need to do. First, they say that you want to prove that origin is the stationary point. So origin is 0, 0. I only prove that the x is 0. I haven't found out what's the y coordinate, right? So I need to sub x equals to 0 into my y. So sub into the y equation of the curve. So it will be y equals to 0 cubed plus p 0 square, and that gives me 0. So you see 0, 0. So you will know therefore 0, 0 is a stationary point. So I prove the first part. So right, shown. Okay. Then they also ask find the x coordinate of the other stationary point, and they only ask for x coordinate. In fact, we already have it here. So you will say therefore the other x coordinate of stationary point is this one, minus 2p over 3. And don't have to worry because they mention in terms of p. So this is the answer for the second part. Okay, next. As usual, they will always ask you find the nature of each of the stationary point. Okay, so let me take a look at my dy dx. Okay, is it easy to differentiate one more time? Okay, pretty easy. So I shall use second derivative test. Okay, so we will do our d square y dx square. It means that I'm going to differentiate this one more time. So I will write d dx 3x squared plus 2px. So we have 6x plus 2p. So this is the function of my second derivative. Okay, but I need to find out what is the value, right? So we need to sub x equals to 0 into here. So sub x equals to 0. So I know my d square y dx square will be equals to 6x plus 2p. Okay, so I get 2p, right? Then you wonder, what is 2p? Is it more than 0 or less than 0? Go back to the question and find the hint. They tell us that p is a positive constant. Means p is a positive number. So if p is a positive number, it means that this is more than 0. And if this is more than 0, it means that it is a minimum point. Okay, so we will know that the first stationary point 0, 0 is a minimum point. Next, I need to sub x equals to my minus 2p over 3. I have to find out what is the value of the d square y dx squared. So 6x plus 2p. Okay, 6x plus 2p. So we will get minus 4p plus 2p, and we get negative 2p. And because my p is positive, right? Negative 2 times a positive number give me negative. So this is less than 0. So if this is less than 0, therefore we know that it is a maximum point. Okay? So to make it very neat, you will say for x equals to 0, it is a minimum point. For x equals to minus 2p over 3, it is a maximum point. Okay, let's just spell it out. Hoi, hoi. Done. All good. So I have used second derivative test to find out whether is it a maximum or minimum. Okay, so that's for question 1, part 1 and part 2. Okay, so there's a part 3 over here. Okay, let me just for those, you can always refer to the replay on the on my YouTube channel. Okay, and then go to my Telegram channel and download the solution. Okay. Okay, now let's take a look at the part 3. Now they tell us another curve, has the equation y equals to x cubed. Okay, I just write it out. Y equals to x cubed plus px squared plus px. This is another curve. They ask you to find These are questions from past year paper. You can see that this is from Cedar Girls AMath Prelim. Okay, so find the set of values of P for which the curve has no stationary point. Okay, so you see, when they say the curve has no stationary point, it means that we want to find dy dx not equals to 0. Okay, so let's find our dy dx first. Dy dx will be equals to 3x squared plus 2px plus p. Okay, so we want to find out what is the range of values of p that will be dy dx not equals to 0. So you look at this. Okay, so we will say for dy dx not equals to 0, it means that you want to have is always positive or always negative, correct? So if it's always positive or always negative, it means that our discriminant is less than 0. So this is linked to Sec 3 topic, which is the quadratic function, the discriminant. For dy dx not equals to 0, it means that they are talking about saying that it is always positive or always negative. And this tells us that our discriminant is less than 0. Understand? Okay, so this is pretty tricky. Okay, then we go and find, okay, so this one we will go and find my b squared minus 4ac. So my a is 3, my b is 2p, my c is p. So b squared minus 4ac, b squared minus 4ac is less than 0. So we will solve 4p squared minus 12p less than 0. You can divide by 4 throughout. I get p squared minus 3p less than 0. So we will have take out common factor p minus 3 less than 0. This is a quadratic inequality, Sec 3 AMath. So you have to draw this diagram. We will know that we have a 0 and we have a 3. Less than 0 means you're going to shade the in-between. So in the end, the p range is less than 0 and, more than 0 and less than 3. Okay? When is b squared minus 4a more than 0? When they tell you that the curve and the line or curve and the x-axis cut at two distinct points. Then you will know that then your discriminant will be more than 0. For this case, okay, we want dy dx not equals to 0. And just nice that our dy dx for this case is a quadratic. So for quadratic to be not equals to 0, it means that they are saying dy dx is always positive and dy dx is always negative. These two situations. And always positive and always negative means that it does not cut the x-axis. It means that our discriminant is less than 0. Okay? This is a bit tricky. This is a tricky question. Okay, let's move on. Question 2. The equation of the curve is y equals to blah blah blah. So let me write out the question. Y equals to 3x squared over square root 4x minus h. They say given that the x coordinate of the stationary point is 1, find the value of h. Okay, they tell me that the x coordinate is stationary point is 1. So that means let's find out our dy dx first. Let's find out what is our dy dx. How to know it is less than or equal? Okay, if you want to talk about discriminant, I'm not going to talk about quadratic functions, that topic. Let's focus on differentiation stationary point. If you want that topic, you can either go to my TikTok, YouTube channel and go and find the relevant. Okay, because we're going to focus on stationary point today, differentiation as well as trigo proving. Okay, so after that, we're going to do our dy dx. Okay, this one, okay, I will choose to use product rule, but it's a fraction now, right? But it's okay, I can bring it up. So we can change this to 3x squared 4x minus h to the power of negative half. Then I'm going to use our product rule. So dy dx will be equals to, keep left, differentiate the right. The right hand side I will apply chain rule. Okay, chain rule. So it will be minus half 4x minus h. Minus half minus 1 is minus 3 over 2. And don't forget to differentiate the inside, which is 4. Now plus, keep right, which is 4x minus h to the power of minus half. And differentiate the left, which is 6x. Okay, so a lot of students, maybe they can reach here, but then they don't know how to simplify. So product rule I have teach in previous TikTok live, whereby I teach differentiation using 5 rules. So you want to learn the basic of differentiation, please go to my YouTube channel. So over here, I will take out the common factor. So 3x squared times minus half and times 4 is actually, we will have a 6x squared. Okay, minus 6x squared. This one and this one is minus 6x squared. Okay, maybe I rewrite. So this one is actually minus 6x squared, 4x minus h to the power of negative 3 half, negative 3 over 2, then plus, this one just I write the same thing. So now we are ready to take out common factor. I'm going to take out 6x as well as 4x minus h to the power of negative 3 over 2. Put a big square bracket. Okay, these two, the bracket is the same, 4x minus h. So we always take out the smaller number. Minus 3 over 2 is smaller than minus half. That is why we take out 6x. How you get 6x? This one? Or this one? I take out common factor. You see, this one is 3x squared times minus half times 4 will give me minus 6x squared. Okay? So these two, common factor is 6x. So I take out 6x. Okay, I take out 6x and I take out this one. So this is the first term. When I take out this, I will left with minus x. That's all. Okay, because this one I will also take out already. Then this part I will left with 4x minus h to the power of 1. Because minus half minus 3 over 2 will give me 1. And because I already take out 6x, so no more. So in the end, close. Okay, so I will have 6x, 4x minus h, negative 3 over 2. This one become 3x minus h. And put this in the form of 6x, 3x minus h over 4x minus h, 3 over 2. Okay, so this is our dy dx. So our task is to do dy dx equals to 0. Where did the 4x minus h come from? No, this is taking out the common factor. There are two terms here. See, there are two terms here. This is one term and this is one term. So I'm taking out common factor from these two terms. And the common factor from these two terms is this 6x, 4x minus h to the power of negative 3 over 2. Okay? So after that, I want to do dy dx equals to 0, right? So let me just write the side here. So I will do 6x. So now I'm doing for dy dx equals to 0. It will be 6x, 3x minus h over 4x minus h, 3 over 2 equals to 0. Okay, don't have to worry. Why? Because we put 0 over 1. When you cross multiply, 0 times the denominator disappears because it becomes 0. So you end up having 6x, 3x minus h equals to 0. Right? So you will have 6x equals to 0 or 3x minus h equals to 0. So x equals to 0 or 3x equals to h, x equals to h over 3. So look back to the question. They tell us that one of the stationary point, the x coordinate is 1. This one is 0. Of course, not talking about this point, right? So it will be this one that they are referring. So x equals to h over 3 is actually x equals to 1. So it means that, therefore, h over 3 is equals to 1. Cross multiply, so I know my h is equals to 3. Done. Okay. Okay, again, product rule, I'm not going to talk in depth again. Go back, refer to my differentiation of 5 rules. Okay, I actually took out common factor. That one I already teach there, so I'm not going to focus on that part. So this is for question 2. Question 2. Again, this is not an easy question. Why? Because this differentiation involves a h. But don't have to worry, just do as per normal. Okay? Okay, let's move on. Wait, next page. Okay, so now let's take a look at question 3. So now we want to do, they want to find dy dx and d square y dx squared. Okay, this is differentiation of exponential. Okay, I write out my y first. Y equals to half e2x minus 7ex plus 6x. Okay, at the side here, I will talk about the differentiation of exponential. Differentiation of, let's say, for example, if I today have e to the power of 3x. Okay, differentiation of exponential very straightforward. It is copy exactly the same. That means e to the power of 3x multiply by differentiate the power. So when you differentiate the power is 3 means you times 3. So in the end it becomes 3e 3x. Okay, so I write in red color and box it up is because it's not related to the question. It is just some method that I want to highlight. Okay, so let's proceed to do our dy dx. So copy exactly the same. So constant also copy exactly the same. Then multiply by differentiate the power, which is 2. Okay, minus 7ex, differentiate the power, which is 1. So I can no need to write, but you want to write times 1 also can. Differentiate 6x is 6. So to look nicer, half times 2 is 1. So I end up having e to the power of x minus 7e to the power of x plus 6. So this is my dy dx. This is my dy dx. Now we're going to do d square y dx squared. d square y dx squared. So differentiate this one. So keep the same, e2x multiply by differentiate the power, which is times 2 again, minus 7ex times 1, and differentiate 6 means disappear. So I end up having 2e2x minus 7ex. And that's all for this part. So this is the dy dx and d square y dx squared. Okay? Okay, next, they ask to find the exact x coordinate of the stationary points on the curve. So why do they want to write the word exact? Because you will have e, the exponential. They don't want you to put, e is actually a number, a decimal. So they don't want you to put in 3SF or what. They want the exact x coordinate. But it's okay, don't have to worry so much because again, they ask for stationary point. So whenever they ask for stationary point means, okay, I'm going to do dy dx equals to 0. Okay, so we're going to do for d square y dx squared means that you're going to differentiate. See, y is a function, right? Differentiate dy dx is to differentiate my y. d square y dx squared means I differentiate my dy dx. Understand? It's like I differentiate one more time. That's why it's d square y dx squared. Okay? Okay, so I'm going to same thing for dy dx equals to 0. So you will take this one. See here. So it will be e2x minus 7ex plus 6 equals to 0. Because when you differentiate exponential, okay, if you are at normal acad, for normal acad AMath, you all don't learn exponential. So you can ignore this part if you are normal acad AMath. This is only applicable for express AMath because express learn logarithm and exponential, but normal acad do not learn logarithm and exponential. Okay. So for dy dx equals to 0. So for this one, I want to solve this by substitution. So actually what I need to do is I let u equals to e to the power of x. So this is actually e to the power of x square minus 7e to the power of x plus 6 equals to 0. So it means it becomes u square minus 7u plus 6 equals to 0. So let's solve this. So we will factorize this, become u minus 6, u minus 1 equals to 0. So we have u equals to 6 or u equals to 1. So it means that, don't forget that you're not solving u, you're actually solving e to the power of x, solving x. So I just temporarily let the e to the power of x be u first. Okay, then when I solve my u, I have to pull back my e to the power of x. So in this case, we will know that e to the power of x is equals to 6 or e to the power of x is equals to 1. Then we need to solve x. So you ln both sides. Ln both sides. I will have ln ex equals to ln 6. Power law tells me that I can bring my x down, and ln e is 1, so x is equals to ln 6. So you see, ln 6 is exact form. Okay, if you're going to press a calculator, it give you decimal. But they want the exact. They want exact. So we leave it in ln 6. Over here, same thing. So I'm going to do ln both sides as well. So it becomes ln ex ln 1. And this one becomes x is equals to 0. So this will be the two stationary points. And they did not ask to find the coordinates. If they want coordinates, means that I need to find the y coordinate as well. But for this question, they only want the exact x coordinate. So this is the answer. These two is the answer. Okay. Okay. Again, they like to ask, what is the nature of this stationary point? So, since we already have our d square y dx square over here, so we can simply use this, sub in these two x value, and find out whether they are positive or negative. Okay? So, what I'm going to do is, first is I'm going to sub in x equals to ln 6. So, my d square y dx square, because previously we already done it here, so we just need to sub in value. So, it's 2e2 ln 6 minus 7e ln 6. So when you press a calculator for this one, you get 72. Yeah, I noticed something. I make an error over here. No, this is not 72. Let me press the calculator again. Okay, wait. So we will key in 2e 2 ln 6. 2 ln 6, correct. Okay, come down, minus 7 e to the power of ln 6. So I get 30, 30. So which is more than 0, it means that this is a minimum point, right? Okay, so we're going to do the same for the other side. So I'm going to sub in x equals to 0. So our d square y dx square will be equals to 2e 20 minus 7e to the power of 0. Okay, and we know that this is 2. 2 times 0 is 0, e to the power of 0 is 1. So this is just 2 times 1 minus 7 times 1, which is negative 5. This is less than 0, it means that it is a maximum point. Okay, so just write the statement for x equals to ln 6, it is minimum point. For x equals to 0, it is maximum point. And we are done. Yep. Okay, For those who know, for those who are in the AMath Express will know what is ln. Ln is logarithm. Normal acad AMath don't learn logarithm. So, like I said, this question is invalid for normal acad AMath. It is only valid for express AMath. Okay? Okay, let's proceed to the next one. Okay, question number 4. So we need to find the coordinates of the stationary point. Same thing. Every time they want stationary point means I want to do dy dx equals to 0, correct? So we need to do our differentiation first. Thanks for sharing. Okay, so let's take a look. So I'm going to write out my y first. Okay, kids, you see here? See here? Here there is a ln x squared. Okay, so I don't want to, always when you want to differentiate logarithm, always apply the laws of logarithm first. Our power law tells us that we can bring down the 2. So this is actually written as 2 ln x. So it's easier for you to differentiate 2 ln x, understand? Okay, so over here, I will rewrite this as y equals to 2 ln x over x. So over, don't ask me why is it that, the question is ln x squared. Why is it that you write 2 ln x? Because I already explained here, ln x squared is equals to 2 ln x. I actually just applied power law. Okay? Okay, then after that, you see this. Okay, how are we going to differentiate this one? The only way out is quotient rule. So let's do our quotient rule. Dy dx is equals to keep the bottom, differentiate the top. Okay, differentiate ln x. Okay, I'm going to state here. When you differentiate ln x is equals to 1 over x. Okay, differentiate ln 3x plus 1 is equals to 1 over 3x plus 1 multiplied by differentiate the inside, which is 3. So this is 3 over 3x plus 1. Okay, this is just additional information on how to differentiate ln. Okay, so keep the bottom, differentiate 2 ln x. So it will be 2 1 over x. Okay, this one I should use square bracket. Okay, keep the 2, differentiate ln x is just 1 over x. Minus, keep the top, 2 ln x, differentiate the bottom, which is 1. Over bottom square, which is x squared. So let's simplify. The x actually cancel out. I left with a 2. This one is minus 2 ln x over x squared. So this is my dy dx. Okay, then to find stationary point, remember dy dx equals to 0. So you will do ln is log base e. Okay, so for dy dx equals to 0, it will be 2 minus 2 ln x over x squared equals to 0. Cross multiply, I left with 2 minus 2 ln x equals to 0. So I have 2 ln x equals to 2, ln x equals to 1. Okay, how am I going to solve this one? Okay, I'm going to put here. So this is base e. Log base e 1. Push up, change to index form. So my x is equals to e to the power of 1. I don't need to write the 1. So this is the x coordinate. See, this one, this time they asked for the coordinate. They did not ask for the x coordinate. Means that I need to find my y coordinate as well. So you have to find y. Remember to sub it into the original y, not to dy dx. Okay, you are not trying to find the gradient. You are trying to find the coordinates. So you need to sub that into the equation of the curve. So sub that into here. So it will be 2 ln e over e. And ln e is 1. So it is 2 over e. Therefore, the point we are talking about is E, comma, 2 over E. Done. Okay? Okay, next, as usual, they ask you to find the nature of the stationary point. Okay, so you see, this is the situation whereby if I want to differentiate my dy dx, I'm going to apply quotient rule again. But quotient rule is so complex. So in this case, I'm going to use first derivative test. Okay, see, so far I haven't demoed to you what is first derivative test. So I'm going to demo using first derivative test because differentiate one more time is difficult. So I'm going to use first test. And thank God there's only 1 point, 1x coordinate, so I only need to draw one table. If you have two stationary points, you need to do two tables. Okay, so let's draw out the box. So you need to draw a box with 9 boxes. The x is equals to E. This is dy dx equals to 0. dy dx equals to 0 means gradient is 0. It is a horizontal line. So the middle one is always like that. And then what is the left of E? Okay, you need to know that E is actually 2.718. So you can put in any values. Okay, a lot of students maybe usually they go and put x equals to 2. But for me, I always put less by 0.1. Okay, so what I'm going to do is I'm going to put in x is equals to 2.7. Okay, then this side I will put x is equals to 2.8. Okay, because E value is 2.718. So the left of it is 2.7. The right of it is 2.8. So we're going to sub in this 2x value into dy dx because we want to know what is the gradient at x equals to 2.7. Okay, so when you press the calculator, take note, you need to sub into dy dx. So my dy dx, for easy reference, I'm going to write here again. So let's do it. So you see, it's fraction 2 minus 2 ln x. My x now is 2.7 over 2.7 squared. Okay, so sub into the dy dx and I press equal. This is a positive value. I don't need to write the exact dy dx. I only need to know whether is it positive or negative. So we will just say, okay, my dy dx is positive. So positive means its gradient is positive, means the line is sloped up. Okay, so now I'm going to sub in 2.8 and see whether is it positive or negative. So put in 2.8. We get negative 7. So this is dy dx less than 0. Less than 0 means its gradient slope down. So the line is this. So look at the line. This is this. Go up this way, right? So this is maximum point. So therefore, we know that E, comma 2 over E is a maximum point. Okay, so this is how you do first derivative test. Understand? You can use 2 or 3, no problem. But the thing is, usually I don't like to use too far away because you never know where is the next stationary point, right? What if it affect and it go down? Because you see, you know what's the theory of using this 2.7? Remember, this is our stationary point. So imagine, this is the point whereby x is equals to E, correct? So I want to know the gradient of my left hand side. So actually all I need to do is I want to know what is the dy dx on my left hand side. So you cannot go too far away. So all you need to do is just a little bit left of E. Okay? A little bit right of E. And so that's why actually it's not useful for you to go and key in like x equals to 2 or x equals to 3. So we always sub in very small difference. Understand? Very small difference, you will be able to know whether what is the gradient at the left and the right. So because of this, then we know that it is a maximum point. You understand? Wait. Did I miss out question? Wait, Ayo. You all ask, is stationary point also called critical point? It is called like that in my class. Oh, is it critical point? Let me Google. We are called stationary point. Let me see what is critical point. Critical points. Okay. Critical point is an inflection point. So do you remember just now we mentioned, okay, here, see here. Remember I said the nature of stationary point, you have three types. Okay, we either have maximum point, minimum point, or point of inflection. So what is point of inflection? Okay, this one I didn't know, but thanks for asking. So now I learned something new. So point of inflection, a second name is called critical point. So what is point of inflection? A line, a curve, let's say for example it's like that. Not like that, okay, too curvy. I should be something like that. Let's say something like that. Oi. Okay, this point. So let's say this is a stationary point. Okay? And this stationary point, because this one go up, it didn't come down. If it come down means it's a maximum, correct? If this one go up means it's a minimum. But for this case, it's a special one whereby it is not a maximum, not a minimum point. So it is called a critical point. But in our syllabus, we call it point of inflection. Okay? Can? So for critical point or point of inflection, when we do the first test, it will be slope down, horizontal, or slope down, or up, horizontal, and up. So these two situations, when you do the first test, it is point of inflection, or you call it a critical point. Okay? Okay. Now let's move on. I think we are done with differentiation. Yes. Okay. So we are done with differentiation. I'm going to do trigo proving already. I'm going to do trigo proving. I mix double angle. I mix addition formula. I also mix identity lah. So let's do it. So this one, first question. Okay. Let me drink water first. At the same time, can you help me to share to your friends who want to learn trigo proving? And for those who haven't followed me, remember to follow me, as well as follow on my Telegram channel and subscribe to my YouTube channel. Okay, you're supposed to prove that this is equals to this. Okay, this one obviously left hand side is more complex, right? Sometimes either way. Okay, sometimes very obvious is you use the complex side to prove to the simple side. So this one definitely left hand side is the most complex. So we will say left hand side equals to, so I will write out cosine theta minus sine theta over 1. Okay, multiply. Okay, see this okay, I'll use bracket. Okay, that's okay. This one tangent theta, I will change it to sine theta over cosine theta. 1 over tangent theta is actually cotangent theta, and cotangent theta is cosine theta over sine theta. So this is plus cosine theta over sine theta. Okay, so what you need to do is, for this bracket here, you need to combine this into a single fraction. So this one, just leave it as it is first. Just write first, no need to do anything to it. So now I'm going to combine into a single fraction on the right hand side. So my common denominator will be sine theta cosine theta. It means that this one, sine theta, must multiply by sine theta. Cosine theta need to multiply by cosine theta. because my common denominator is sine theta cosine theta. Okay, and I will get this one, no change first, just keep it the same. This one become sine square theta plus cosine square theta. And we all know that sine square theta plus cosine square theta is equals to 1. So I'm going to write here, I'm using the sine theta plus cosine square theta equals to 1. That's the formula for, that's the first identity. Right? This is the formula that you will see during exam. You have sine square A plus cosine square A equals to 1. So that's why sine square theta plus cosine square theta equals to 1. Just put at the side here. So I will know this is 1. So we end up having cosine theta minus sine theta over, because this one become 1 already. So this one become just sine theta cosine theta. Okay, and because now you can see that they want to split to have a minus, right? And you see the denominator. The denominator is only one term. There's no plus minus. It means that I can split this. Okay? So I will split this to become cosine theta over sine theta cosine theta minus sine theta over sine theta cosine theta. Okay? And cosine theta can cancel. Sine theta can cancel. You end up having 1 over sine theta minus 1 over cosine theta. And that is cosecant theta minus secant theta, which is equals to right hand side. Shown. Understand? So, in here, proving, a lot of times you need to change to single fraction. So what I did here is, you need to know that tangent theta is equals to sine theta over cosine theta. This one is must know one. And you also must know that cotangent theta is cosine theta over sine theta. So in this question, I have made use of this knowledge. Okay. Then after that, after changing this, then I combine into a single fraction. Okay, sometimes it is not obvious what I need to do, but the only thing we can do here is to combine into a single fraction. So combine into a single fraction first, then after that see what you can do. So you see, after I combine into a single fraction, I get sine square theta plus cosine theta. So in the end, I know I can change this to 1. So since this one become 1, combine into a single fraction for this whole thing, because this one is multiply, so this one go to the denominator. And then my denominator is only 1 term, means I can split. So after split, it becomes this. Understand? The PDF worksheet will be uploaded to my Telegram channel. You can go to my bio, click on the last button, join my Telegram channel. The PDF worksheet will be uploaded tomorrow, okay? Okay, let's move on to the next question. Again, this one, obviously, the left-hand side is more complex. So we're going to start from the left-hand side. So we will write left-hand side equals to, always write out the original question first. Secant x plus tangent x squared. Okay, look at the right-hand side. The right-hand side is in terms of sine. So that means I need to change them to become sine and cosine. So third letter C, so this one we know that this is 1 over cosine x. And this is sine x over cosine x. And denominator is the same, cosine x. So we're going to combine it into a single fraction. So it becomes 1 plus sine x over cosine x squared. Okay, so let's do this. It will become 1 plus sine x squared over cosine square x. So I will open up this one. This is a plus b squared. So it's a squared plus 2ab plus b squared. So it's a squared plus 2ab plus b squared. Actually, no need. this one I shouldn't expand. Okay, this one just keep it this form, keep it this form. Okay, I shouldn't expand this one, just keep it. I'm going to change the denominator. Okay, you need to know that when we have sine square x plus cosine square x equals to 1, okay, make sine x, if I make sine square x a subject, it is sine square x equals to 1 minus cosine square x. Okay, if I make cosine square x the subject, it will be 1 minus sine square x. So we always use this when we want to change sine square x to be in terms of cosine square x, or when we want to change cosine square x to be in terms of sine square x. So in this case, my denominator is cosine square x. So we're going to change it to 1 minus sine square x. So, wrong pen. So we will have 1 plus sine x squared over 1 minus sine square x. Okay? And the denominator is actually a squared minus b squared. Again, we're going to use the a squared minus b squared is equals to a plus b and a minus b. Okay, this is the factorization. So denominator become, okay, numerator no change. I'm going to write out 2 brackets. Denominator become 1 plus sine x, 1 minus sine x. And these 2 is the same. So I'm going to cancel them off and I'm left with 1 plus sine x over 1 minus sine x. And it is the same as the question, which is equals to right hand side. Shown. We are doing proving trigo. Okay. So this is how you do this question. Okay, let's move on to the next question. So you can see that this question, I make use of changing cosine square x to become sine square x. Then I also make use of a squared minus b squared is equals to a plus b, a minus b. Okay, and again, I also make use of combine to a single fraction. And again, I also change my tangent x to become sine x over cosine x. And you need to know that secant x is equals to 1 over cosine x. Look at the third letter, it's a C, so we know that it's 1 over cosine x. Okay, so trigo proving, you need to know all of your trigo identity and how you, that's a lot of knowledge to be used in trigo proving. Okay, let's move on to the next question. Okay, this one is differentiation of trigo. Okay, I think I accidentally put this question here, but never mind, it's okay. Anyway, it's trigo, so okay, because we are supposed to do trigo proving, right? I got and this one is differentiation. Never mind. Okay, so anyway, this question is also good, because just to recap, okay, when you differentiate sine x, it is equals to cosine x. Okay, when you differentiate cosine x, it is minus sine x. When you differentiate tangent x, it is equals to secant square x. So differentiation of trigo, only these 3. So now they ask you to differentiate cotangent theta. Then you look at it, don't have that. I only have 3. How to do differentiation of cotangent theta? No need to panic. Remember just now I have talked about cotangent theta is cosine theta over sine theta. Change into cosine theta over sine theta first. Okay? So I will write here, cotangent theta is equals to cosine theta over sine theta. So therefore, to differentiate cotangent theta, it is the same as differentiate cosine theta over sine theta. Then the bad news is we have to use quotient rule. Okay, so keep the bottom, which is sine theta, differentiate the numerator, which is minus sine x. So it is minus sine theta. This one is x, but this one is theta, so you got to use accordingly. Then minus, oh no, no space. Keep top differentiate the bottom, which is cosine theta, okay, over bottom square, so it's sine square theta. So I have minus sine square theta minus cosine square theta over sine square theta. Then how? Let's take a look at the question. Okay, you can see that our denominator is sine square theta. It's already almost there. So again, we're going to use the popular identity, which is the sine square x. For this case, it's sine square theta plus cosine square theta is equals to 1. It's just that you need to do one more step. Take out negative 1. Take out the common factor. So I'm going to take out negative 1. I'm left with sine square theta plus cosine square theta over sine square theta. And this one is 1, right? So I end up having minus 1 times 1 over sine square theta, which is equals to negative 1 over sine square theta, which is equals to right hand side. Equals to right hand side shown. Done. Hello. Okay. So this is how I differentiate cotangent theta, by changing it to cosine theta over sine theta and then applying quotient rule. Okay. Okay, next, question 4. Prove that blah 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 blah. Okay, this one, technically speaking, left side, right hand side also equally complex. But left hand side is more complex. Why? Do you see that the power is 4? Okay, so for this question, I will start from the left hand side. So left hand side is equals to cosecant 4x minus cotangent 4x. Every time you see power 4, I know that it will be linked to this formula, which is our a square minus b square is equals to a plus b, a minus b. So this one, I will rewrite this as cosecant square x square minus cotangent square x square. Okay, a square minus b square. So in this case, my a is cosecant square x, my b is cotangent square x. So now it becomes a plus b, a minus b. Okay, a plus b, a minus b. And look at the identity over here. Okay, I'm going to use the identity, okay, right out here. I'm going to use the identity which is cosecant square a equals to 1 plus cotangent square a. So in this question, we are going to use this one. So this is cosecant square a, the subject. So now I do another one which is cotangent square a, the subject. So it becomes cosecant square a minus 1. Okay, so I'm using these two. Oh, actually one more. Can shift one more. See, this one, cotangent square a, if I bring over, cosecant square a minus cotangent square a equals to 1. And see, this one is exactly the same as this right hand side, correct now? So this bracket become 1. So over here, I'm going to just write cosecant square x plus cotangent square x. This is 1. Okay, then after that, look at the question. You can see that the question is in terms of cosecant square x. So in my proving, I already have my cosecant square x. I have this extra cotangent square x. But in my identity, I have a cotangent square a that I can change it to in terms of cosecant square x. So I'm going to change the cotangent square x. So it becomes cosecant square x remain the same. I'm going to change this to become cosecant square x minus 1. Okay? So, do you see that these two is like terms? So this is like x plus x, so it becomes 2x, right? So it's actually equals to 2 cosecant square x minus 1, which is exactly as the right hand side. So this is equals to right hand side shown. Okay. Good. So far, okay? So, remember, in fact, proving a lot of times they like to use the a square minus b square. Huh? So, when you see 4 power 4, no need to panic, definitely is linked to a square minus b square. So, your a is your got square, huh? Your b also got square. Okay? And then after that, I have changed it to a plus b, a minus b. Then, how do I derive that I'm using this identity is, after I do my a square minus b square, then I look at my right hand side. My right hand side is in terms of cosecant square x. Then you look at what you have. I have extra cotangent. Then you look at back to your formula sheet. Okay, formula sheet. Then you see, oh, okay, I have the third one, which is I can link my cosecant square a and cotangent square a. Because of this, we are able to find cotangent square a, change it to cosecant square a. And I'm also able to have the cosecant square a minus cotangent square a is equals to 1. So from this one, then I change, and we get the exactly the same. Okay? So this is how I do question 4. Huh? Must be you are hardworking that time. Math is all about practice, okay? Always practice, because math always have different variety of questions. It's only about practice, then you have more confidence in doing them during exam, okay? Okay, let's move on to question 5. Okay, scan. So this one, okay, this one obviously is my left hand side is more complex. So sometimes at one look you don't know what to do, okay? But the very straightforward thing I can do is only to expand first, then see what we can, okay? So let's write out the left hand side first. So my left hand side is cosine A plus cosine B square plus sine A plus sine B square. Okay, so let's just rainbow out first. So this is actually just a plus b square. So we will use a square plus 2ab plus b square. So you will write it as cosine square a plus 2 cosine a cosine b plus cosine square b. This one same thing. So expand, I get sine square a plus 2 sine a sine b plus sine square b. Okay, and it is going to use the popular identity, which is the, so I just put here. By now I think you all should memorize that sine square x plus cosine square x is equals to 1. So let's take a look. So we have cosine square a and plus sine square a. So this one gives me 1, correct? Then we have another one, cosine square b and sine square b. So this one gives me another 1. So 1 plus 1, we have a 2 already. So we have 2. Then after that, this one just rewrite. I'm going to write plus 2 cosine A cosine B plus 2 sine A sine B. Okay, you can look at the question. You can see that this is the addition formula. Okay, so my formula, addition formula, cosine A minus B. See, so over here, cosine A minus B, it is cosine A cosine B. Okay, if this is minus, this is plus. So we know it's cosine A cosine B plus sine A sine B, which is exactly here, but I need to take out my common factor 2. So we will put 2 plus 2, open up, I have cosine A cosine B plus sine A sine B. And this is okay, I need to write the formula. Okay, so it will be cosine A plus minus B is equals to cosine A cosine B minus plus sine A and sine B. Okay? So therefore, it becomes 2 plus 2 cosine A minus B. And we're done. So this is equals to right hand side, shown. Okay, so you see, at one glance, you will not know what to do. Okay, you will not know, okay, I'm going to use this identity. Okay, you can just expand first, because the only way out is you must expand first. So expand already, then see what you can do. And then I can say, oh, I can make use of my sine square x plus cosine square x equals to 1, and I end up having two of them, two sets. These add up to become 1. This one add up to become 1 again, so I have a 2. Then this one just rewrite and copy down here. And then I take out common factor 2, I left with this bracket. And this bracket is using the addition formula for cosine. And I can change it to cosine A minus B. And we are done. Okay? Okay, let's move on to the next question. Okay. So over here, this one definitely left hand side is more complex. I'm going to just rewrite. Left hand side is equals to 1 plus sine 2x plus cosine 2x over cosine x plus sine x. Okay, so what can we do? Look at the right hand side. The right hand side is single angle. That means it's not double angle. So that means I need to change my sine 2x to become single angle, and then I have to change my cosine 2x to also single angle. So sine 2x, no way to change, no other ways to change. You only have one formula. So I write here, we know that sine 2x gives us 2 sine x cosine x. Okay? Okay, the cosine 2x, we have 3 choices. Okay? Cosine 2x, I have 3 choices. Okay, our 3 choice will be cosine square x minus sine square x, or I can change it to 2 cosine square x minus 1, or I can change it to 1 minus 2 sine square x. Okay, my cosine 2x can change to either one of them. So then the next question is, this cosine 2x, should I change it to the number 1, number 2, or number 3? We shall see. Okay, so first change our sine 2x. So it is 1 plus 2 sine x cosine x. Okay, then now is, I don't know what I need to change here. Denominator is cosine x plus sine x. So which one should we change? Okay, easy. What you need to see is, look at the right hand side. My right hand side is cosine x. So I want to have as many cosine as I have, right? So I'm going to change to the second one. So this cosine 2x, I'm going to choose the second one. So it becomes 2 cosine square x minus 1. Do you see the 1 minus 1? Disappear. I only left with the 2 terms. So I left with 2 sine x cosine x plus 2 cosine square x over cosine x plus sine x. So what I need to do is the numerator, I'm going to take out common factor. Hello, Mobile Legend. Okay, so I just take out common factor. So the only common factor I have is 2 cosine x. So take out 2 cosine x, I left with sine x plus cosine x. Cosine x plus sine x. Can you see that these 2 brackets is exactly the same? Cancel. So therefore, I end up having 2 cosine x, which is equals to my right hand side, shown. Okay, so in this question proving, I have used the double angle. I make use of the sine 2x to change to 2 sine x cosine x. This one got no other way of changing. There's only one identity. Cosine 2x, we have 3. So I choose to change it to cosine is because my right hand side is in terms of cosine. So I want to have as many cosine I have. That's why I change it to 2 cosine square x minus 1. Okay, another reason is also because if when I change this to minus 1, I can have a 1 minus 1, which I can make it disappear, you see. Okay, so this is how I do question 6. Okay, we left one last question. One last question. Ta-da! Okay, this one, okay, this one not that tough, okay. Okay, let's see. So this one, left hand side and right hand side looks equally complex, okay. But because this one got minus, okay, so when we have minus or plus, we have a possibility that we can combine to a single fraction. So we will start on the left hand side. So my left hand side is equals to cotangent. Can do the vector with bearing and all, please? I did the vector last lesson already. Please go to my YouTube channel and take a look at the vectors. Bearing long time ago, I already did before. Please go to my YouTube channel. Go to my bio. Click on the second last button, which is subscribe to my YouTube channel. You can see a lot of videos there. Okay. Left hand side is equals to cotangent x minus tangent x. What can you do? Remember our very first question that I mentioned that cotangent x is cosine x over sine x, tangent x is sine x over cosine x. Change that first, okay? So this is cosine x over sine x minus sine x over cosine x. Then what can we do? Remember we always say combine into a single fraction first, then we see what we can do. So combine into a single fraction. So my common denominator, we will know that it will be sine x cosine x. So this top part will be cosine square x. Then the top, this one will be sine square x. So in this question, we are using the cosine 2a is equals to cosine square a minus sine square a. And I will also be using this. Sine 2a is equals to 2 sine a cosine a. Okay, this one a little bit tricky. Okay, see here. My cosine square x minus sine square x is actually just changing it to cosine 2x. So my numerator become cosine 2x. Okay, now the tricky part is denominator. This is sine x cosine x. It is not 2 sine x cosine x. So what do I do? Very easy. See, from here, right? If I write 2 sine a cosine a is equals to sine 2a, right? Then I just divide by 2 throughout, divide by 2. So it means that my sine a cosine a is equals to half sine 2a. So over here, we will change the sine x cosine x to become half sine 2x. And you should know that 1 divided by half is 2. So you end up having 2 multiplied by cosine 2x over sine 2x. And cosine over sine is what? Cotangent. Okay? So therefore, it is 2 cotangent 2x, which is equals to right hand side. Shown. Ta-da! And we are done. So in this question, we are still using the double angle. Okay? I'm using the not so popular one, cosine 2a. We have 3 choices. I use the first choice. Okay? We use the first choice because this one obvious. The numerator is straight away is the first choice. Okay? Denominator, we need to do, sorry, not denominator. The sine 2a, we need to manipulate a bit. Whenever you see sine x cosine x, we know that we can change it to double angle of sine x. But this one don't have the 2. But it's okay. It means that sine a cosine a is half sine 2a. Understand? So half sine 2x. And then 1 divided by half is 2. And then times this one. So it becomes 2 cotangent 2x. Okay, and we are done. No, I only teach Sec 1 to Sec 5. Not doing any P6 question. And we are done.